Welcome to the second part of our alien shooter game. In this video, we will finish the game logic. To start off, I will add a script tag just before the end of the body tag. Now I will create a new file in the same directory called script.js, which will contain our game logic. We're grabbing the canvas element from our HTML so we can draw on it. The CTX variable gives us access to the 2D rendering context. Basically, it lets us draw shapes, colors, and animations. We also grab some other important elements like the overlay that appears when the game ends, buttons to restart or change difficulty, text fields to display the score and wave, a toggle for turning sound on or off, an instructions box to help the player. These are all for controlling or displaying parts of the game. I will get those elements in variables named Game Over Overlay, Restart Button, Score Display, Wave Display, Final Score Display, Difficulty Buttons, Instruction Box, Close Instructions Button. We want our game to look good on any screen, so we're dynamically resizing the canvas. This section limits the width to 600 pixels max, maintains a 4:3 aspect ratio, uses a resize observer to update the canvas if the container resizes. I will create a dimensions object which will have a height and width. I will create a variable named container element, which will be our container class. Then I will get the minimum value between the container element, actual width, and the 600 pixels that we want. The height will be 4 to 3 from the width, and then I will set those values to the canvas. Now I will call the update dimensions function that we've just created and create the resize observer, which will observe our container element. We also want to call our update dimensions function each time a resize is triggered on the browser window. This section sets up our core game state. We track the player and enemies, bullets currently on screen, score and current wave, booleans for whether the game is running, settings like difficulty and sound. Think of these as the brain of the game. They hold all the important data we'll keep updating. We will have a variables for player, bullets, enemies, score, wave, boolean for game running, animation ID, difficulty, enemy speed, enemy fire rate, player fire rate, last fire time, initial enemy count for wave and enemies destroyed for this wave. You can set the same default values as me or experiment with your own. Now I will set up some utility functions. Random helps us get a random number. Check collision checks whether two objects are overlapping. We use this for both bullets hitting enemies and enemies hitting the player. Here we define factories, reusable functions that return game objects. Create player returns the player ship's properties and position based on the canvas. Create bullet can make bullets for the player or enemies here. Again, we will have X and Y for the position, width and height, and a flag as player that will set different values. Create enemy lets us create different types of enemies. Basic, normal speed, fast, smaller, quicker. Tough takes 2 hits. This modular design makes spawning and modifying enemies super flexible. I will be setting my colors and stats for the enemies and bullets. You can set the same values or experiment with your own. You can even add a different types of enemies. Now let's break down one of the most important parts of our game, the spawn enemies function. This is the function responsible for creating the alien army for each wave. Let's go through it step by step. First, we reset the game state for the new wave. We clear out any existing enemies, reset the count of destroyed enemies, and also reset the total count of enemies we'll track for this wave. Next, we determine how many rows of enemies to spawn. We increase the number of rows based on the wave number, but we cap it at 5 rows to keep the game balanced. We're placing 8 enemies per row, and we calculate the horizontal spacing between each one based on the canvas width. This ensures enemies are evenly spaced across the screen. We also define vertical spacing between rows to stack them nicely. We use 2 for loops, one for the rows and another for the columns inside each row. Each enemy starts out as a basic type by default, but as we reach Wave 4 and beyond, we introduce variety. We use a random number to occasionally replace basic enemies. We will also calculate each enemy's X and Y position based on its row and column, add some margin, and call the create enemy function to generate the object and add it to the enemy's array. Now that we've spawned enemies and bullets, let's focus on drawing them to the screen, starting with the player spaceship. Here we're using the HTML5 Canvas API to draw a custom spaceship shape. CTX fill style equals player color. This sets the color of the spaceship using the player's defined color. CTX begin path starts a new drawing path. Then we use move to and line 2 to draw a triangle that looks like a spaceship. Finally, we use close path to connect the last point back to the first one and fill it in. This gives us a simple but effective triangle spaceship pointing upward. Drawing bullets is even simpler. Each bullet is just a colored rectangle. Enemies are also drawn as colored rectangles, but they vary in size and color based on their type. This will be all for this video. Follow along in part 3 where we will complete our game. If you like this content, please consider subscribing to the channel and don't forget to leave a like. Let me know what other topics and projects you would like to see on this channel. As always, stay frosty, and I will see you in the next one.